presentation is soil structure and rocks for erosion, grade prediction, and rock sediment depth.
Hello and a very good morning to everyone. My name is Mohammed Shahid Salim. I'm going to talk about my research related to hydrodynamic erosion of soil. And the title of my current paper is Soil Partition Apparatus for Erosion Expedition with Smooth and Rough Pebble Base. This was actually my MSc project. My thesis supervisor was Dr. Ravindra Jaranga, and co-supervisor was Professor DC Vajtikara. And this project was a part of mathematical and physical modeling of hydrodynamic erosion of soil funded by the Graduate School of UEL under the Promising Research Fellowship 2009-10 owned by Dr. Jaranga. Presentation outline. First of all, I would like to tell about the motivation. Why did we choose this topic and why we are interested in this research, and then aims and objectives. And third, I will talk about the laboratory experiments and results. Basically, we did the experiment in two stages. First of all, we did some experiments based on the smooth bed, and now we are going to do some rough bed experiments. And this paper is related to the preliminary experiments that we did for rough bed. After that, I'll talk about the mathematical model. Actually, we developed in our previous conference papers, in research papers, two mathematical models for erosion and prediction. And finally, I will go for conclusion, picture one, and knowledge. Motivation. Most common cause of hydraulic structure is related to erosion or drought. And this highlights the need of closer monitoring of field conditions and fundamental study of hydrodynamics in the area of soil, especially when we start 1 year back, more than 1 year, in 2009. At the end of the year, there was a very catastrophic flood in Cumbria, in UK, and we focused on that, and we noticed so many bridges that have been collapsed, very bad bridges because of erosion. And we focused on those studies and did our work related to that one, quite a bit similar on that one, why those bridges have been collapsed. We tried to investigate on that. This project is already been half done, so there are a lot of things to go. And erosion prediction methods are necessary to minimize the hydraulic structure failure. And our target is to design just to predict the soil erosion more accurately, because if we just do the under design, the bridges, the structures may collapse, and even if we do some more over design, then unnecessary construction costs will come out. So that is the basic purpose. And then soil erodibility coefficient, that is related to the mathematical model. We got some sort of coefficient that will be helpful to calculate the soil erosion properly. Aims and objectives. To do this work properly, we developed in our university laboratory a new apparatus and named it as soil partition apparatus. The main purpose and the benefits that we are getting from this apparatus is to choose the right parameters, the right perfect parameters that is needed to figure out the phenomena that is involved in hydrodynamic erosion of soil. The influence of various soil properties and design parameters are also being investigated. That is one of the objectives. Then the patterns of sediment plumes, the SPA, in short, the soil partition apparatus, we call it as SPA. So in that SPA apparatus, we have a plastic plume, so it's very easy and convenient for us to have a look properly how the soil is eroded and what mechanism is involved over there and what patterns we can get it from for the prediction of soil erosion. And finally, a theoretical model for erosion rate in terms of measure parameters to predict, as I say, to predict the soil erosion properly. Previous laboratory studies, according to erosion apparatus. First of all, in 1962, Moore and Nash, they developed a rotating cylinder apparatus. I don't want to go in depth, but the thing is that in this case they use inner and outer rotating cylinder just to calculate the soil erosion. Just to calculate the shear stress that is that applies to hydrodynamic erosion of soil. And in this case, they calculate the torque in between the inner and outer rotating cylinder. And in 1986, Rohan he tried to improve the previous apparatus and introduced a three-hole apparatus which was quite similar to the previous one. And he and in 1994 they introduced a vertical bridge oscillator. They introduced a bit different from the previous two, and they mentioned something about rotating Higgs device. And finally, Philogeny and Brown in 1996, they just tried to combine all previous apparatus and try to use the latest technology on that. And after that one, Dr. Brown in 1999 and 2001, he introduced the erosion function apparatus, which is called as EFA, and to check out, just to get to know the soil erosion, the scour rate and all issues. Soil perfusion apparatus, SPA. This apparatus that we developed in our laboratory at the University of East London. The SPA was developed with the following specific goal. Basically, to perform the site-specific erosion study to minimize the sample disturbance so that we can get the real phenomena that is happening in our riverbed and coastal area and all those things. We incorporated results in the erosion prediction method, then to investigate separately the responses to erosion of various types of soils, and finally to reduce the measurement error using video recording technology. We use the digital technology to minimize the chance of having some errors in our measurement. Concept of SPF. Basically, hydrodynamic erosion of soil system can be categorized into three different stages. Erosion with obstacle, erosion without any obstacle, and channel migration. So basically, our main concern was related to the first one, erosion without any obstacle. As you can see in this case, this is the real natural condition, natural bed, and the bridge pier or any hydraulic structure is standby on this footing, and the soil bed boundary is there. And in the second case, we assume the bed as fixed, and we assume the erosion is in without any obstacle. And then in the laboratory, this is the in-between condition of field and lab. And third one, it is showing the laboratory condition where the bed is smooth plastic bed and it's fixed. And the basic reason why we did this one is we want to see the top level of soil, how it reacts basically with hydraulic terms. So that's why we fixed the bottom. I mean, we consider the bottom as fixed. This is the experimental apparatus, the smooth bed setup in our laboratory. This is the whole setup of SPA. This is the 100 mm sample core tube while we pour the sample, and you can see the 5 mm sample in the tube core. This is the SPA piston that we rotate to get some proper perfusion from 1 to 10 millimeter, from 1 to 10 millimeter. And then SPA, this is the diagram that we use, and our HD digital camera that we mounted on top of the sample code so that we can record each single experiment to analyze later on. And the last one is about the flow visualization using the potassium permanganate. And the other one, the previous slide, was about the previous investigations that we did in our previous research paper. And this is all about the current paper that I'm going to talk about. This is the rough bed. We used 2 centimeter layer of sand to develop the, to increase the roughness. And here you can see the sediment SPHU. Now it looks like this one, and after perfusion, it seems to be 5 millimeter thickness. And this is the water flow with potassium permanganate again to visualize the sand properly. And finally, you can see some crescents. I'll talk about more about this crescent in upcoming slide. This is the smooth bed condition. There is no sand, and the grade, the plan view is the end view. There is no sand, as you can see, and in the plan view you can see the grade. That was quite helpful to the images properly and using AutoCAD and other software to analyze later on. And this is the rough bed condition. Now we will have a 2 centimeter layer of bed. And in this case, we can't see the grade because we used sand on top of that. So the only possibility was the camera. I mean, using the camera as the object, we did all the drawings in AutoCAD and all the area calculations in AutoCAD. Test condition, up to now we did 303 experiments in up to 1 year, and it takes a long time for each experiment, around half an hour. So the smooth and rough bed experiments were been done. Actually the smooth bed conditions and the experiments, we did a conclusion on that from 0.115, 0.26, 1.3, 0.75 and 2.4 diameter of sand we already been used. And next one is about the rough. In preliminary case, we use only 0.3 millimeter sample, and we will show the further extension of our work in our upcoming days. This is the data collection process. Here you can see we collected the data for each experiment in 3 different stages. We collected from manual data source, we have the instrumental data source and the digital one.